Cartesian coordinates and a Euclidean space. We have a parallel pipe. Actually, this is a rectangular box in the three-dimensional space. We first choose the origin at a vertex and choose the A, B, and C. We would like to move from the origin to point C. Using vectors representing the sides, we can introduce a small a vector that connects the line from the origin to A. B is connecting starting from A, ending up at point B. And we have a right triangle, and we know the sum of A and B connected by the head and tail of two vectors, we can construct the sum of the two vectors. Because this is a rectangle and these two vectors are side vectors, this is nothing but the diagonal. That means a rectangle, the diagonal connecting O and B has only a single diagonal. So we have A plus B is the same as B plus A. So we have a diagonal, uniquely defined diagonal, satisfying the commutative law. Commutative law is not taught by mathematics, but the physics of space is governing the world, states that commutative law must satisfy. So sum of A and B can be written either A plus B or B plus A. Okay, and then I'd like to go further by elevating by this vector C. Then we have A plus B and B plus A, both of them represent a single diagonal. And then why don't we add C? Then finally, we obtain a resultant vector called A plus B plus C. Actually, we have so many possibilities of obtaining this resultant vector. For example, this, any kinds of paths will give the same result. And actually 3 factorial. If we reorder this, the sum, A, B, C, B, C, A, C, A, B, and so on, any kind of combination will give the same vector. A, B, B, C, C, A, scalar product. Aha. A, B, C are parallel to E1, E2, and E3. Any unit basis vector of Cartesian coordinate system, the scalar product must vanish for any case, except that it is a scalar, it has a scalar product with itself. That is one. What is the way of proving the Pythagoras theorem with Cartesian coordinates? Yes, we have done this in the previous class. What is the length of A plus B plus C? Okay, length of a vector is the square of a vector and then square root. That is the magnitude. Okay, we know what A plus B plus C is, and we know A is A E1, B equals B E2, and C equals C E3, and they are all orthogonal to each other. So if you square this, we have this, and 2AB, 2BC, 2CA. all of these guys cancel because E1 dot E2 equals 0, E2 3, 3, 1, 0. Everything is 0. So what we obtain is sum of squares and the square root. So this is the length. Aha, because the three axes, x, y, z axes are perpendicular to each other. Therefore, the two-dimensional version of triangle can be extended to this three-dimensional version of the triangle. So if you look at this, this is a triangle, and we have A, B. So the length of this is A squared plus B squared. And this is also a right triangle. This side is a C. So the length of this hypotenuse is square root A squared plus B squared plus C squared, the square root. And this is trivial. This is A squared plus B squared and plus C squared. Aha, three-dimensional case is a simple extension of the two-dimensional case. Compute the area of a triangle in terms of scalar products. Using these, we can compute the area of a triangle. Okay, triangle. This is a triangle. So base multiplied by height multiplied by 1/2 base times height. Okay, so elementary school students know how to compute this. So we copy this formula. You know, is the same. So you double to make it as a parallelogram and multiply 1/2 of base and height. Okay. So how can I find the height? Perpendicular component. Perpendicular component. How can I find the perpendicular component? I need to subtract the parallel component. How can I find the parallel component? Using scalar product. So any vector can be decomposed into parallel and perpendicular component relative to A. So now n hat is replaced with A. What is the parallel component of vector B parallel to A? This is trivial, okay? Just project the A direction only. And then, because A hat is a magnitude of A, and this is a square root of A vector squared, then A, I substitute in here. There are two hats, so we have two square roots to have denominator A squared. And every factor has a vector. So this one, A vector, B scalar product, and this one becomes A vector. Just to count the number of A's in the numerator introduced. So there are two factors. We have A squared in the denominator to make the same dimensions. What's next? So perpendicular component can be obtained by subtracting the parallel component from the original vector. This is a trivial algebra. Now the area of a triangle is 1/2 base times the height. And height is, middle school students know that the height is length of B multiplied by the sine theta, where theta is the angle between A and B. Now we compute this B per magnitude. B per magnitude can be obtained by squaring this vector, and take the square root. Square A alpha plus beta squared equals alpha squared plus 2 alpha beta plus beta squared. Okay, so this is alpha and this is beta. we have squared this a to the fourth b squared, this is squared, b dot a squared, scalar product and multiplied by 2. So minus 2 a squared b dot a, and but b dot a double square. I noticed this guy, they are similar. Only the difference is a factor of minus 2 and plus 1. So this one can be simplified into this. Now I find that it's a squared b squared minus a dot b squared. What's that? We have magnitude, this base a in here. This is the square root of a squared. They cancel. So finally, we obtain this. By the way, what's that? I can factor the magnitude length A and length B out 1/2. This is each side, this side, and this is square root 1 minus something squared. However, this A dot B divided by A magnitude B magnitude is nothing but cosine theta. Haha, 1 minus cosine theta squared, the square root is a sine theta. It was a trivial calculation. Let theta be the angle between the two vectors A and B. Express cosine and sine. As far as cosine is concerned, what we have done, we just have shown this. What is the sine theta? We already have shown this. So this is cosine and this is sine. We will make use this formula frequently in the future.